One of the things our students enjoyed a lot was sumo, robot sumo. So let's see what we can do about that. We'll change to intermediate, we'll get rid of the code, and to do this we have to use an optical distance sensor to detect the difference between the white inside of the sumo ring and the black outside. This is an example that Modern Robotics give us, which is this one, and we can try running this. When we run it, in fact, with one thing we've got to change this. We've got our optical distance sensor in slot A1. Now if we run this program will start working. Now there's some new code we haven't seen before here. One of this is a repeat statement. Now repeat while true, it'll always be true, we don't change that in this case. So it goes down, it does this statement, read optical distance sensor, it waits 1/10 of a second, then it comes back and it keeps looping around and round and round. So what happens when we read an optical distance sensor? This is our optical distance sensor on the front of Fusion. It throws a light down below. That light, that red light, is reflected back from that black surface, and the optical distance sensor measures how much reflected light there is. It then sends that number back to the cable to our core controller and then back by Wi-Fi to our computer. And that's the number we see here, which I think is it's a lower number because it's on black. Now later on we'll move the Fusion robot forward so that the optical distance sensor will be on white. White reflects more light back, and so the number sent back to the core controller and back to our computer by Wi-Fi will be higher, probably something like 10 times as high. And eventually we stop this run by pressing on the stop device up here. Okay, so let's see that actually running. We'll find we're getting readings around about high 160s, low 170s when the optical distance sensor is over black. If we move it over white, we'll get readings of round about 1023.